Hey, welcome back everyone. Today we're going to continue working on the greedy questions from the LeetCode roadmap. So in the previous video, we finished the first 4 questions right here. So today we're going to finish the next 4 here. So let's get straight into it. The first question is hand of straights. So in this question, Alice has some number of cards and she wants to rearrange these cards into groups so that each group is group size and consists of group size consecutive cards. So we're given an integer array hand. This is the hand we have of a bunch of cards, and we want to split them into different groups of group size. And we want to return true if we can rearrange these cards and false otherwise. Remember that the cards in each group have to be consecutive. So looking at example 1 here, our hand is 1, 2, 3, 6, 2, 3, 4, 7, 8. So to rearrange them into group size consecutive cards, first of all, we see the 1 here. So because the 1 is the smallest card, it has to be the smallest one in the consecutive 3 set. So the 3 consecutive cards stemming from the 1 are 1, 2, 3. So this is the first group, as you can see here. So after that, we look at the rest of the cards. So we see that 2 is the smallest card. So beside 2 has to be 3 and it has to be 4 because this is the smallest consecutive cards stemming from 2. So after removing 2, 3, 4, we're left with 6, 7, 8. These cards are also consecutive and there's exactly 3 cards, so we can rearrange them into the final group here. So because we can rearrange these cards into 3 sets of 3 and they're all consecutive, we can return true as our output. So in example 2, we're given a hand of 1, 2, 3, 4, 5, but the group size is 4. So if we rearrange these cards into a group of 4, we're left with 1 card left over. So because hand mod group size is not equal to 0, we're going to return false because it's guaranteed we can't split them into even groups of 4. So in this question, this is a greedy question because right off the bat, we can see that we always want to start with the smallest card at every iteration. So because the smallest card has to be the smallest card in its own group, that means it has to take the next card, which is 1 plus the smallest card, and then 1 plus 2 plus the smallest card, so 1, 2, 3. These two have to be in a group together no matter what, because of the existence of 1. So after we deal with 1, 2, 3, we can remove that from the hand. Then we can look at the next smallest card. So the next smallest card here is going to be the 2, because 2 has to be in a group with 2, 3, 4. Since 2 is the next smallest card, we can remove 2, 3, 4 from the hand. Now what we're left with is 6, 7, 8. The smallest card is going to be 6. So we can take away the 6 as well as 7 and 8 because they have to stem from the 6. So after that, we notice that hand has no more cards, so we can return true. So if we do the same operation in example 2 here, we're going to start with the 1. There's going to be group size is 4 this time, so we have to take away 1, 2, 3, 4 together. So we try to do the same operation starting from 5, but we notice that we can't take away 5, 6, 7, 8 because they don't exist. In which case we want to just return false. So in this question here, we can create a counter. So a counter in Python just counts how many variables or how many numbers there are in the hand. So counter is equal to a counter created from the hand. This is just a map, and this counts the instances each card. And we should also have a set to look for all the numbers in the hand and make sure they're all removed, because at the end, hand should have no more cards. So using a set, we can look for the unique numbers in our hand. So nums equals to a set, and it's created from the hand as well. So nums is going to record the number of unique cards remaining, or which unique cards there are that are still remaining. And because we said we always want to start from the smallest card, we can sort nums and start from the smallest number in nums. So let's do for card in sorted nums. So we sorted the set, so we're going to start with the smallest number. In example 1, that would be 1 here. So starting from 1, we need to make sure there's still instances of the 1. So while counter card is greater than 0, that means there's still instances of this card inside our hand. In which case we want to remove the card as well as the cards that are adjacent to it, that are greater than it. For example, if we're looking at the 1 and group size is 3, then we want to get rid of the 2 and the 3 as well. So we can use a for loop with size group size to do that. So for I in range, starting from the card, and the range should be size group size. So let's do card plus group size. Because the for loop here, this one is going to be not inclusive. So this range is going to be size group size. So for every card in this range, we're going to want to decrease it by 1. But first of all, we should make sure that this card I is existing in the hand right now. So if counter at I equals to 0, then we want to return false, because the card we want to remove is not in the hand anymore. However, if that's not the case, we can do counter at I decreases by 1. So we're going to repeat this process again and again until we get rid of every card in the hand, or we reach this false instance, where we cannot remove a card that we want to remove, in which case we want to return false. So if we're done getting rid of every card in our hand, so every card in sorted nums is set to 0 now, because this while loop makes sure every card is greater than 0. So once the instances of every card is set to 0, then we can return true. So let's return true here. Let's try running it. Cool, that worked. So let's submit it. Nice. So this question's time complexity is actually just based on the number of cards there are, because although there's a for loop here and a while loop here, we can just look at the inside for loop. So this for loop is going to remove group size cards at a time. So how many times does this for loop run? Well, it's going to run hand divided by group size times. And this for loop itself runs group size, so let's do a comment here. So the for loop, it's going to run hand size, let's call it hand size divided group size times, and each time it takes group size time to run that. So multiplying the number of times it runs by how much time the for loop takes to run, we're going to get the time complexity of the function, which is going to be hand size, which is just the len of the hand. So that's this question, always starting from the smallest card, for example, the 1 here, and then removing the ones that we must remove, for example, the 2, 3, and then repeating the process until we either have no more cards or we're left with cards and we want to return false. So that's hand of straights. Let's move on to the next question. So merge triplets to form target triplet. In this question, we're given a triplet, which is an array of 3 numbers, and we're given these triplets as a 2D integer array. So triplets, they have 3 fields, let's call them A, B, and C. And we're also given a integer array target, which is also a triplet, but it has X, Y, and Z. So this is the triplet that we want to obtain. And to obtain this target, we can do this operation here. Let's call that the max operation. So basically for every 2 triplets, we can do a max of AI, AJ, BI, BJ, CI, CJ. So for example, if we have 2 triplets, 2, 5, 3, and another triplet, 1, 7, 5, combining these triplets or doing their max operation is going to take the maximum of the triplets at every slot. So looking at the first slot, or the A slot, we're going to take the maximum of those, so maximum of 2 and maximum of 1, which is bigger, 2. So the output is going to have 2 in the A slot, or the first slot. So in the second slot, we're going to compare 5 and then compare 7. 7 is larger, so we're going to have 7 in the second slot. And now in the third slot, we're comparing 3 and comparing 5. So 5 is larger than 3, so 5 is going to be in the third slot. So after doing this operation, the merged triplet here is going to be 2, 7, 5. So in this question, we want to return true if it's possible to obtain this target by merging some triplets, or false otherwise. So let's look at some examples here. In example 1, we're given triplets 2, 5, 3, 1, 8, 4, and 1, 7, 5. So the target is 2, 7, 5. In this case, first of all, we want the 2 in the very first slot, or the A slot. So the only way to get the 2 is with the first triplet, because doing the max operation, it has to take the larger one, which has to be one of the triplets. So that means we must use the very first triplet. So now if we want to get a 7 in the second slot, that means we have to have a 7 in one of the triplets in the second slot. So we can see that in the third triplet, it has a 7 in the second slot. So we're going to do the max operation on the first triplet and the second triplet. So the first slot is going to be 2 because 2 is greater than 1. The second slot is going to be 7 because 7 is greater than 5. And in the third slot, it's going to be 5 because 5 is greater than 3. So now we notice that just doing the merge operation on the first and third triplet, we obtain the target. We don't even need to use the second triplet at all. So let's return true in this case because it's possible for us to make the target triplet. So now looking at example 2 here, we want to make 3, 2, 5, but we're given 3, 4, 5 and 4, 5, 6. So we can see that what we want to obtain, or a 2 in the second slot, is not existing in any of the triplets. It's a 4 and a 5 in the second slot. So no matter how we merge these triplets, well, there's only one way, but how we take these triplets, we're never going to be getting a 2 in the second slot. So we want to return false because it's impossible to make this target triplet. So in example 3 here, we're given a bunch of triplets. Our target is 5, 5, 5. So we notice that there's a 5 in the second slot, a 5 in the third slot, and a 5 in the first slot. So we can do a merge on all these triplets that contain a 5, and we're going to obtain our target 5, 5, 5. However, there's something else that we should notice. So for example, in the first triplet, suppose this 3 is not a 3, but instead it's a 7. So if we were to use this triplet to merge with the other triplets, that's going to cause the last slot, or the third slot, to be a 7 in our target, in our obtained triplet. Because our target has a 5 and 5 is smaller than 7, we can never go back. We can never get a lower third slot. So if this slot is a 7, then this triplet is no longer usable because it's going to cause our obtained triplet to have a 7 in the third slot, and that is not what the target wants. And we can't use the merge operation to make any slots smaller. We can only make them bigger. So if this were a 7, then the first triplet is rendered useless. We cannot use this, and we have to look for another way to get 5 in the second slot. But there's no more 5s in the second slot. So if this 3 is a 7, then this triplet is useless, and this question to return false instead of true. So now we have a basic understanding of how to solve the question. Essentially, we want to find a way to make the first slot, the second slot, and the third slot. But the triplets we use, they have the other slots. For example, we're using the 5, so the second slot, but the third slot and the first slot have to be smaller than what the target wants. Okay, so let's create the target. So the target is going to be x, y, z, and let's have these be variables. So they're all 0, which represents false. That means we haven't obtained this target yet. So x is going to be the first slot of target, y is going to be the second slot of target, and z is going to be the third slot. So all of these are 0 because we haven't obtained any of them yet. So now looking at our array of triplets. So let's do for, actually let's just let x, y, z be equal to target. So this is not rendering. It's not going to be representing whether or not we obtained it yet. So let's let first, second, third, these variables should represent whether or not we obtained the triplet at that spot. And x, y, z is just going to be representing the slot on the target. For example, in this case, x, y, z would be 5, 5, 5. So now we can do a for loop throughout the triplets to see if we can have a matching number at the correct slot. So for A, B, C in triplets, so A is the one that we want to match with x. So if A is exactly equal to x, that means we can use this triplet. But if and only if the other slots, for example, the B slot and the C slot, are less than y and z. Otherwise, this triplet is useless because it's going to create something that's larger than the target. So if A is equal to x, and also B is less than or equal to y, and C is less than or equal to, forgot the and here, and C is less than or equal to z. So if this is the case, then what we want to do is set first equal to 1. That means we found a triplet that allows us to create the first variable inside target. So now let's do the same thing looking for the second variable. So if B is equal to y, and now we have to make sure A and C are not larger than their corresponding triplet targets. So and A is less than or equal to x, and C is less than or equal to z, then we can set second equal to 1, or second equals to true. So now if C equals to z, that means we found something for the third slot. So if C equals to z, as well as A being less than x, and B is less than or equal to y, then third should equal to 1. So we set all of these to be equal to 1, and if that's the case, then we can return true, since we're able to create target exactly in all 3 slots. If any of them are not 1, then we're not able to do that. So we can return first and second and third. So we need first, second, and third all to be true for us to return true. If one of them is false, then we're going to return false. Let's try running that. Cool, that worked. So let's submit it. Nice. So in this question, notice that I used 3 if statements instead of any elifs or elses because we need all of these to be executed since it's possible for a single triplet ABC to match exactly X, Y, Z. So in a single run of the for loop, we should be able to set first to true, second to true, and third to true. If A is equal to X, B is equal to Y, and C is equal to Z. So we can't use any elifs or elses because those are not going to execute and it's only going to execute one of these if statements. So that's this question. Let's move on to the next one. So partition labels. In this question, we're given a string S and we want to partition the string into as many parts as possible so that each letter appears in at most one part. So note that the partition is done so that after concatenating all the parts together, the resultant string should still be S. So it should be the input. And now we want to return a list of integers to represent the size of each of these parts. So this question is a little bit confusing when just reading it. So let's look at the examples here. So in example 1, the first partition is size 9. So it's going to go all the way to here. So we want to do it in as many parts as possible so that each letter appears in at most one part. So all the letters in the first partition can only appear in the first partition. So looking at all the A's, there's no more A's after this partition ended. Looking at the B's, there's also no more B's. Same with C's. So this should be here. This is 9. So that's the first partition. Looking at the second partition, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. Oh, it should be 7. Okay, whoops. So it should go all the way to 1, 2, 3, 4, 5, 6, 7. There's going to be no more D's, no more E's, no more F's, G's, or D. Already said D's. So there's going to be no more repeated characters after every character in this partition has been used. So finally, in the last partition, because there's more H's later, we can't partition this H. There's more I's later, we can't partition that I. So we go all the way until the end, and that's going to be a single partition. So we want to partition the string into as many parts as possible. So at every character, we always want to try to see if we can partition it. So let's look at example 2. We want to try to partition it at the E, but that's not possible because there's more E's later on in the string. So the string has to be at least this, the concatenation has to be at least this long. So looking at this partition here, there's going to be C's here, but there's still C's later on in the string. So it's impossible for us to partition this string into more than 1. Which means our output is going to be 10, or the length of the partition, which is the length of the entire string in this case. So now we have a basic understanding of how to do this question. So essentially at every character, we want to see if there's more instances of the character in the string. So because there's more instances of the A, we can't make a partition here, we can't add 1 to the output. So instead we have to look for the next character, A, B. So now we have to look at 2 different characters, A and B, and we want to see if there's more instances of A or B later on in the string. So they are, so this is not a valid partition either. So we're going to continuously do this all the way until we can see that there's no more characters or no more instances of the characters inside our current partition, in which case we want to make a partition and then start fresh again. So in this question, we want to return an array of integers, which represents the size of the different partitions. So let's call that answer, and that's going to be an empty list at the start. So now we should also keep track of which characters we've seen in our current partition. So let's create a set for that since we don't want duplicates. So seen equals to a set. We should also create a counter to count the instances of every single character inside our string S. So that way we know whether or not there's more instances of each character and that we've yet to see. For example, if there's more instances of A that we've yet to see, that means we cannot make a partition right here. So let's create a counter to help us do that. So counter equals to a counter created with the string S. And also we have to keep track of the start of our current partition. So let's call that variable start. And at the start or at the beginning, it's going to be initialized to 0. So now for every character, so for I in range, starting from 0 all the way to the length of S, we want to see if we can make a partition. So first of all, we have to add the current character that we see into our scene set. So scene.add, what we want to add is s at I. So now the counter of the current character should decrease by 1 because we've seen this character, and counter should represent the number of occurrences in the entire word. So since counter counts the occurrences in the entire word, if we've seen it, that means the count that we've yet to see should decrease by 1, which means counter at s at I should decrease by 1. So now if there's no more occurrences of every single character inside our scene set, that means we can make a partition. So we're going to create a helper function. Let's just call it for now. So if no more partitions based on scene and from the counter. If that's the case, then we can make a partition. So if we make a partition, first of all, we should clear our scene set. So scene.clear. We should also add the length of the current partition. So the length is going to be starting from I minus s minus start plus 1, because it's inclusive of I. So we want to increase the size of I minus start by 1. Now we want to start fresh. So start is going to be the next character. So start equals to I plus 1. After that, we can just return our answer. But before running the question, we need to code this no more partitions function. So no more partitions, or let's not call it no more partitions, let's call it no more occurrences. So no more occurrences is going to return true if there's no more occurrences of every character in scene. Otherwise, it's going to return false. So def no more occurrences. It's going to take in scene, so the set of characters that we want to try, and the counter, the number of instances of those that are yet to be seen. So for every character in scene, if counter char is greater than 0, that means there's still instances of this character that are yet to be seen, in which case we want to return false. So if we've checked every character in scene and we haven't returned false yet, then we want to return true. There's no more occurrences of every character in scene. So if this is true, then we can make a new partition. So let's try running that. Cool, that worked. So let's submit it. Nice, that worked. So this question, the time complexity is going to be O of n based on the number of characters inside our string. So this has a for loop in it as well, the helper function, but there's only going to be 26 different characters, lowercase characters in English. So it's going to be O of n times 26, which is still O of n. So the big time complexity comes from this for loop here, where we check every character in the string s. So let's move on to the next question. Valid parentheses string. So in valid parentheses string, we're given a string s, and it contains only 3 types of characters. We have the left parentheses, or the opening parentheses, the right parentheses, or the closing one, and a star, which is a wildcard character. So we want to return true if s is valid, or false otherwise. So we have a set of rules to define a valid string. So any left parentheses has to have a corresponding right one, any right parentheses has to have a corresponding left one, and the left one must go before the right one. So that's the same for every parentheses matching question. However, what's special about this question is that we have a wildcard character. So this character could be treated as a right parentheses, or a left one, or an empty string. So this can be anything that we want or nothing at all. So looking at the examples here, first of all, s is just a left and a right. That's obviously going to be true. So in example 2, we have a wildcard character, but because the wildcard character can just become a empty string, that means example 2 could just be the same as example 1, which returns true. So in example 3 here, we have 2 right parentheses, only 1 left. So we want the wildcard character to be a left parentheses. So if it's a left parentheses, then it's going to look like this, and in which case we want to return true. So this question, it can be done in a variety of ways, but I think the simplest way to do this question is to keep track of how many left parentheses there are at every instance. And whenever we have a right parentheses, then we want to remove the number of left parentheses by 1. So whenever we bump into a wildcard character, however, the wildcard character is going to potentially be a left one or a right parentheses, in which case we can either increase or decrease the number of left parentheses by 1. So instead of just counting the number of left parentheses, we can create a range for the left parentheses. So the range is going to be composed of a minimum and a maximum. So let's call that left min and left max. So initially, it's going to set to 0 and 0. There's no left parentheses whatsoever. So now for every character in S, if we bump into a left parentheses, so if character is equal to an opening 1, then left min plus equals to 1, and left max plus equals to 1. So if we have a left parentheses, then the number of left parentheses must increase by 1. We don't have an option here to decrease the minimum or increase the maximum at all. So now if, let's do an elif char is equal to a closing parentheses, that means we have to consume one of our left parentheses. So the left min and left max should both decrease by 1. Left min decreases by 1 and left max decreases by 1 as well. So what gets interesting is when we hit the wildcard character. So let's do a else clause here. So if we hit the wildcard character, we can either set that to be a right parentheses. So let's say wildcard character is equal to a left, or it could be a right parentheses. In this case, how do we do it? Well, we can decrease the number of left parentheses by 1. So we're going to decrease the minimum of the range by 1. So let's move this comment here. So it's also possible for this wildcard character to be a left parentheses. So left max should increase by 1. The wildcard character is equal to a left parentheses. It's also possible that this wildcard character is equal to an empty string, but that empty string is going to not change left min or left max. The empty string is going to be within the bounds of minimum and maximum. So now after this, we want to make sure that we're not at a point where there's only a closing parentheses or only a right one. So we want to make sure left max is less than, if left max is less than 0, then we want to return false. Because no matter how many left parentheses we want, the maximum number of left parentheses we can generate at this point, if it's less than 0, then we want to return false, because it's going to have one more right parentheses than left at the current point. So in that case, we want to return false. So now another case we have to consider is if the minimum number of left parentheses is less than 0. So for example, if we start with a wildcard character, then left min starting at 0 is going to decrease by 1, left max is going to increase by 1. However, left min is going to be -1 in this case, but we never want left min to be -1 because we can never have a negative number of parentheses. So whenever this happens, we can just set left min to be equal to 0. So if left min equals to 0, or if left min is less than 0, we should just set left min to be equal to 0. A nicer way to do this is just with a max function. So left min equals to max left min or 0. So those two do the same thing. We're just setting left min to be 0 if it's less than 0. So now at the end, we want to make sure that every left parentheses is matched by every right parentheses. So we want to say the number of left parentheses that are left over that are unmatched is going to be 0. So instead of having a count of left parentheses, we have a range. So we want to make sure that 0 is within the range of minimum and maximum. So we can return left min is less than or equal to 0, which is less than or equal to left max. So 0 represents that every left parentheses is matched by a right parentheses. So if 0 is in the range of the possible number of left parentheses, then we want to return true. If it's not in the range, so it's impossible, that means it's not matched. That means a left parentheses is not matched, in which case we want to return false. So let's try running this. Cool, that worked. And let's submit it. So this question is going to be time complexity O of n based on the number of characters in S. Because we're only running this for loop a single time, and we're only keeping track of two different variables, the minimum number of left parentheses and the maximum number of left parentheses. So whenever we bump into a left parentheses, that means both the minimum and maximum must increase by 1 because there's no option there. If we have a right parentheses, then they both decrease by 1 since it gets matched. However, if we have a wildcard character, then we can decrease the minimum and increase the maximum, since we don't know what this wildcard character is going to be yet. So whenever we have too many right parentheses, that makes left max less than 0, so we return false. And whenever we have left min equal to something less than 0, that means we had a wildcard character at the start, and we set that to right parentheses, which is impossible. So we want to reset left min to be 0. In the end, we want to make sure that every left parentheses is matched with something on a right parentheses. So in which case we want 0. But because we have a range, we just want to make sure 0 is within this range. So that's it for this question, and that's it for the greedy questions from the LeetCode roadmap. So thank you guys so much for watching, and hope you're able to learn something, and I'll see you in the next video.